Alright guys, 2.9, proving lines parallel. Today we're going to do two things. We're going to recognize angle pairs that occur with parallel lines. Okay, pretty much a review of something we've already talked about. And then number two, we're going to prove that two lines are parallel using those kind of rules that we've talked about. So here we go. The first thing here is what we call the converse of corresponding angles postulate. Now, you're going to see this a lot in geometry where we have the converse of something. So if we have one thing that you've already seen, you may not remember it, but we did already mention the corresponding angles postulate. The corresponding angles postulate basically said that if you have corresponding angles within a set of parallel lines cut by a transversal, that you know that those angles are congruent, right? So basically we said in the past, if these two lines here are parallel that are shown, corresponding, just a reminder, means that the angle here is on the same side of the transversal, but one is inside, one is outside. So these two angles here are what we call corresponding. Okay, so in the corresponding angles postulate, you learn that those two things are congruent. Okay, so this is the converse of that. So what we're saying now is if we have two lines that appear to be parallel cut by a transversal, and we know that, let's just say that this angle is 50 degrees, and we know that this angle that this is pointing to down here is also 50 degrees. If those are the same, then we can then assume that the two lines are parallel. Okay, so it's called the converse because we're basically using the rule in reverse. We're saying that if those two things are the same, then the two lines are parallel. All right, so that's the converse. Next, we have the parallel postulate. What this is saying is if you have a line, so we could just draw any line, right, assuming that it's a straight line, and a point not on the line, so I can put that right here, then there exists exactly one line through this point that is parallel to the given line. So in other words, you can only have one possibility of a line that's parallel to the other one. Because if, so I just showed you an example of what that might look like, assuming that I was drawing straight lines. But let's just say we didn't make this parallel, but you still had that same point. Okay, to show you a non-example. Okay, if you used a line with a different slope, even if it was just like a little bit off like this, what you would see here is that eventually, somewhere out in space, these two things would cross, so they're not truly parallel. So for them to be parallel, they'd have to have the exact same slope, which means there's only one line that goes through a point outside of another line that is going to be parallel to another line. Okay, that's the parallel postulate. Got a couple more of these for you guys. Just make sure you guys get these in your notes. There are also pictures on page 208 in your textbook if that helps you to look at that. So here we have, if two lines, this is called the alternate exterior angles postulate. If two lines in a plane are cut by a transversal so that a pair of alternate exterior angles is congruent, then we know that the two lines are parallel. Okay, so again, this is kind of like the converse. This probably should say converse on it. Basically, if you have, if you look at, we can zoom in on this picture here. Okay, if you have these two lines here, right, that appear to be parallel cut by a transversal, 1 and 3 are examples of alternate exterior angles, right? They're on either side of the transversal, they're both on the outside. Okay, so if those two things are the same, we can assume that the two lines are parallel. That's what this is saying. Okay, the alternate exterior angles postulate converse. Then we also have the consecutive interior angles converse. Okay, so that other one was supposed to have a converse on it. So here the consecutive angles, remember for consecutive, I'm going to zoom in on that one here. Oh, sorry about the bell. So it says here, if two lines in a plane are cut by a transversal so that a pair of consecutive interior angles are supplementary, remember what that means? 180 degrees, if they add up to 180 degrees, then we know the lines are parallel. So that's like this example here. Okay, we know that if these two lines that appear to be parallel here, cut by a transversal, if we looked at this angle 4 and this angle 5, those are called consecutive interior angles. If those add up to 180 degrees, then I know that those two lines are parallel. I'm just using the law in reverse. Okay, so if this was, let's say this was 80 and this was 100, okay, if that was the case, then I can say P is parallel to Q because the interior consecutive angles add up to 180 degrees. They're supplementary. All right, so that's what that rule is. Next, we have the alternate interior angles. So remember that rule. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. So that would be like this example here. Okay, so these are alternate interior angles. They're on either side of the transversal. They're both on the inside of the lines that appear to be parallel, so they're interior, alternate interior. Okay, if those things are congruent, then I can say that those two lines are parallel. So if you said, you know, if 6 is congruent to 8, then I know that P is parallel to Q. All right, and then finally, I think this is the last one here, guys, the perpendicular transversal converse. In this one, if you're in a plane, if two lines are perpendicular to the same line, then we know they're parallel. Okay, so here, okay, if this line here is perpendicular to this one, and Q has the same slope, okay, then if they're truly parallel, these would both be right angles. If one's a right angle, the other is a right angle. Okay, that's the perpendicular of the postulate. So if you know one's 90, and this one is also 90, then you know that P is parallel to Q. All right, so those are the main rules. Now let's just go ahead and apply those. So here, for example, 1, it says state the lines that are parallel given the angles listed and name the theorem that justifies your answer. Okay, so we're looking for two lines cut by a transversal. That's important. So for 2 and 8, let's just highlight these. So for 2 and 8, 2 is here, 8 is here. Okay, so what I want to point out here is because we have two, what appear to be two parallel lines, right? So we need to look at the one that we're focused on. So for this one, I would call this my transversal, and I would call these my parallel lines. Okay, so if that's the case, the relationship between 2 and 8 in that scenario there is that they're alternate interior angles. So alternate interior angles converse tells me that if 2 is congruent to 8, then I can say that A is parallel, and that's the short abbreviation for parallel. Instead of writing it all out, you can just use those two lines. A is parallel to B. Okay, and the reason is we have alternate interior angles that are congruent. So we use the alternate interior angles converse to say A is parallel to B. Okay, so let's look at 1B. If we are looking at angle 3 and angle 11, okay, again, it'd be important to note that this would be the transversal on this one. Okay, these might be the parallel lines if we have a rule. Okay, so what's the relationship between 3 and 11? Those are corresponding, right? So you can say here that L is parallel to M by the converse of corresponding angles. So you'd write that out, right? Okay, then 1C, let's try this one out here. 1C, we have 12 and we have 14. Those look to me like alternate exterior angles, but let's just make sure. So this would be the parallel line to this, cut by this transversal. Okay, and in that relationship, these would be alternate exterior. So you would say that A is parallel to B. Okay, A is parallel to B. And the relationship here is alternate exterior angles postulate converse. All right, so that's 1C. Then 1D, we have 1 and 5. So, 1 and 15. Let's cruise right along here. So for this one's an interesting one, okay? So for here, you know, if we were trying to use these two, you know, if you went this way with it and you said these two lines are parallel, cut by this transversal, okay, then there's no relationship between 1 and 15, right? Because that's on a different transversal. And if you went the other way, tried to go the other way with this, if you said this was the parallel lines and this was the transversal, again, these are on different, these relationships here between 1 and 15, they're on different transversals. So for this one, there's none. There's no parallel lines that we can say for sure because there's no relationship between 1 and 15. Now, it would be different if we were talking about 5 and 15, okay, because those would be alternate exterior on the transversal here. But these are on different transversals, therefore there's no relationship. So you got to be careful. Once in a while, they'll throw one of those at you. Okay, let's look at just a couple more here, and then we'll go to example 2, and then we'll be done. So here we have the measure of angle 8 plus the measure of angle 13 is equal to 180. Okay, so if that's the case, then we're talking about this being parallel to this, cut by this transversal. Okay, and in that, the relationship there is consecutive. So this is the consecutive angles postulate converse. And we can say that in this case that L is parallel to M. Okay, so it's important to trace those out and to identify those. Finally, we have 8 and 6 here. For this one, we have this guy and this guy. So we can say that possibly if we looked at these two cut by this transversal, right? For F here, is there any postulate that we could use to say that that those two things are parallel? And the answer to this is no. Okay, we can't say anything's parallel here because these are vertical angles. So we know something about this, but we don't know anything about this and the other line, right? It's just this intersection. So you always need two intersections on the same transversal, okay, it's for this to be a valid reason. So here we would say none again. Okay, we can't state anything about this, right? If we said this was, for instance, if we said this was 50, we can use vertical angles to say that this is 50, right? And then if you knew that that was 50 and that was 50, then you would know that this was 80 and this was 80. And then you could, so this is just a technicality here, you could say that 8 is congruent to 16. Okay, so if you use that chain of logic, then you know that this is 50, and that 7 is congruent to 15, so that's 50. Okay, but you'd have to assume that these were parallel in order for that to happen. And this is asking you, use what you know to prove that something is parallel. So we can't say that anything is parallel, but if we knew they were parallel, then we can use those relationships. So sorry if that confused you, but just know that you can't prove two lines are parallel unless you have two different intersections with the set of parallel lines that you're looking at. So you'd have to have two different intersections on the same transversal. Okay, that's what you're looking for, and you didn't have that there. Finally, example 2 says find y so that E is parallel to F. Show your work. Okay, so if these are truly parallel, what we know from the postulate about perpendiculars is that if this is a 90-degree angle, if these are truly parallel, this would have to be 90. If that's 90, due to our linear pair rule, we know that this would have to be 90. Okay, so we'd have to set this to equal 90. 4y plus 10 equals 90. If that is true, then we know they're parallel. So that's what we're trying to prove here. So if we do this, we get 4y is equal to 80, therefore y is equal to 20. Okay, so that's how you would work something like example 2. All right, guys, that's it. We'll do some more in class. Catch you guys next time.